Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 162. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. This one is threshold majority queries. It is apparently a very well-known problem-ish. I didn't know it, to be frank, so I did not solve this one. I tried a lot of different ideas, and actually I did know some core part of this idea, but I just never learned it. I mean, I even knew the name, honestly, but I just never learned it because it just never came up. So, which is to say, apparently, in the past, you can become a grandmaster or a red and top coder or whatever without knowing stuff like this. And honestly, also doesn't make this problem that interesting, if you ask me, in the sense that it took me about like 5 minutes of reading actually this doc, and then I was able to come up with like from scratch. And you can watch the live portion if you're curious how I learn new things. I just kind of read the doc, and then I kind of wrote my own thing in my own way, and then in 10 minutes I got it AC, right? So it's not super interesting. That said, it did not work in Python, so I translated it to Java, but the idea is fine. We'll go here today, and with this problem, most of the problem is actually the idea. The code is not that interesting, even though somehow Leetcode does find a way to time out in Python anyway. But yeah, so for this problem, I'm going to go really briefly over Mo's algorithm. It is an idea from square root decomposition. Yeah, I'm not gonna lie, I did learn this literally like right before this video or whatever, right? So it's a test one for everybody, you know. One of my professors used to say, the first time you teach something, the teacher learns. The second time the teacher teaches something, the students may actually learn. And the third time, nobody learns. I don't know. Joking aside, probably. I don't know, because I didn't learn that much. But in any case, yeah, so this is my first time, so we'll see how that goes. Let me know in the comments if you have questions, or come to the Discord. Because actually, honestly, at this point, my Discord is full of really smart people who works very hard as well. They know this algorithm, so they're teaching me now. So yeah, at least for stuff like this, right? Just because, yeah. But also, honestly, I don't think this one is intractable as long as you kind of have a little bit of, just background about this analysis, and we'll go over it and we'll see how understandable it is and how to kind of come over it. Okay, and apparently I would say this is a very standard. I mean, this is literally like the example used in the other doc, right? So yeah. So the idea with Mo's algorithm is that it's and this is square root decomposition in general. It's just this idea of amortization, right? And how to do or breaking things down in a when I was taught this way back like 20 years ago now, more than we used to call this like a big universe, small universe. You do something with a big universe, you do something with a small universe, and then so forth, right? So okay, so without knowing anything about square root decomposition, the idea here is that, okay, let's say we have an array of length n, we break it down to I don't know, just say a block size of b, right? Doesn't matter what it is for now, right? We just break it down this way, and this algorithm assumes that the queries that we have are offline, right? Meaning that you can reorder them, we can rejuggle them, so that we can do them all at the same time in a batch kind of way, right? And then the idea here is that, okay, given this block, now we have an array. I represent an array in like, something like this, and let's just say there are a lot of elements. Let's say there are a lot of elements, right? So yeah, so the idea here is leveraging a sort of sliding window. And here we can just pick up some sort of a block. Again, for now, it's not important what the analysis is. I mean, of course, they should be the same size, and then ... right? And then now for each block, we want to sort all the elements by the block ID, if you will, right? Meaning that, okay, So you have n elements. You have each block that is size b, right? That means that that means that there are two things, right? You have n over b blocks, right? Because each of them are size b, you have n over b. I mean, we'll say that it goes in perfectly, like divisible and stuff like that. So there's no extra for now. It doesn't matter, right? But so n over b blocks, right? Yeah, and after you sort them by this ID, and the block ID is just index over b. It's pretty straightforward, right? And the reason is because you almost another way to think about this. I always do anyway. I know not many people don't think of it that way, but I just think about like this is the like if you have a base b number, it's like the first digit or something, right? Something like that. But in any case, and the idea really is just that because you have n over b blocks, the first b is going to map to 0, right? And then now and this is the for function, just to be clear. And then the second, well, I don't know why I have an f here. Well, the second b element would have 1 ... 2 ... right? Okay, so now you have, and as I said, you have n over b blocks. And basically we just sort by this, and also without going into too much detail yet, we also sort the right endpoint from left to right, right? Okay, so what does that mean? Then now we can do a very basic sweep line algorithm, right? Or actually, sorry, a sliding window, right? Because how would a sliding window work? Well, a sliding window for this problem would just it's pretty straightforward. I mean, it's not really. It is a sliding window, but it's almost like it's not a sliding window in the traditional sense. It's just more that you have a window and you want to make the window your query, right? So now you're given these. As I said, you sort all the queries. You sort all the queries by these blocks and the right endpoint. So the block ID, I just call it block sub I, and then the right endpoint, right? I just call it all for the right endpoint. So then now, what does this mean? That means that now you're trying to extend a window, right? So then the window has two sides. Let's just say we have L and an R for whatever, right? And we get queries in this way, right? And this is the window that we adjust. And then now when we get results, what does that mean? Well, that means that all the blocks, all the queries where the left endpoint is in the same block will be in L, right? So L is bounded by it's in say from 0 to, at least in the beginning. I mean, b sub 0, right? Something like that, or b sub 1 maybe. I don't know. Right, and maybe that's b sub 0. But yeah, everything is from 0. It's not b sub 1. It's actually no, it's b. Yeah. Sorry. It is actually b exactly, right? Maybe -1, but yeah, L is in this range by the definition of how we structured it, and then R, because we sorted it, will go from left to right, right? So that means that L will let me step back for a second. Sorry, like I said, this is new to me too. So then now, okay, so this is your current window, and then now you say you have a new query coming in, right? Change the color real quick. You have a new query coming in, and then the new query has a new L and a new R, right? And all you have to do is just move them, right? So for example, if this is your window, your current window, and let's say L is here, or L and N is here, and I don't know, R is here, the new N or new R is here, then you just move L to the left and move R to the right. Keep in mind that for the R, well, for two things. One is that if all the L is the same, if all the L is the same, if all the L are in the same block, then R sub n will only go from left to right, right? And because it goes from left to right, that means that, well, this is going to be increasing, right? Okay. And L of n, because everything is in the same block, for each query, we will only move as only O of B moves, right? At most, so maybe the way I would rewrite this is that R is increasing, and L will make at most B moves, right? Yeah. And this is for each query. So for each query, there are two ways to think about it. Two different ways. Oh, sorry, they're not different ways, but there are two components that we have to think about: analyzing the L and analyzing the R, right? And as I said, L moves. Oh, what the? I know that I'm reiterating a little bit, but L moves B blocks, right? Or B moves, because that's the size, of the block, right? So, wow, that is terrible handwriting. But okay, you get my idea. I always said L only moves B moves at most because it is in the same block. R just increases. And why do I say just increases? Because it actually, if you kind of look at the amortization of R, because it's increasing, then that means that at the very end of this block, at the end of block 1, R can only go from, say, all the way to the left side to the right side, right? I mean, it may stop, and some may jump harder than others, but it just goes from all the way to the left and all the way to the right, right? So that means that, yeah. And so that means that amortized, this is going to be at most O of n, right? So that means R moves O of n for this block, right? Of this block of queries, right? All right. I'm going to pause for a second here and step back a little bit. So I'm just giving you some concepts to kind of digest and think about. But let's step back a second. I just said that, for here, and maybe this part I did take for granted, so I didn't explain it in detail. But let's just say you start with, man, I've used every color. Hang on. So you start with a window of like no element, right? So LR is in the same place. And then you kind of expand R to the right, L to the left, and then kind of just move it around. And as you add elements, then I didn't mention this part because I just forgot, honestly. But as you add elements and as you remove elements, as you're going from left to right, you just have to keep track of the most frequent element in the interval. And this is what the problem asks you for, so this is good, right? So that when L and R is equal to the L and R of this current query, then now this is your answer, right? Because you just expand it and, So that part is pretty, we'll go over it in code, but the TLDR is that you just use a heap, right? Or something like a sorted list or something like that. When you add an element, you keep track of its frequency, update the frequency in a heap or something, see if it's the max. If it is tie, then do the tie breaking thing. So stuff like that, right? I know that I'm hand waving that part, but I feel like that part is a sliding window problem. That is a Leetcode problem that you should be able to solve as a prerequisite. So I don't want to spend too much time on it. But yeah, so I want to spend more time on obviously the Mohs algorithm, the more complex part, right? Anyway, I want you all to, okay, so if not, then take a pause and then kind of focus back on this, which is that, like I said, L moves at most B times, R moves at least O of n times for the entire block, right? Well, so what does that mean? Well, let's say it's easier to separate the analysis, I think. So I'm gonna do that. But so that means that how many times does R move through all the queries, right? Well, we just said that there'll be n over B blocks, and each of those blocks will take O of n for R, right? So how many, so then the analysis in an amortized kind of way is how many times does L move and also R move over all queries, right? And for R, there are n over b blocks. Each block takes O of n. So this is just very basic multiplication, right? It's n over b times n, right? So all of this for right. And then what about left? Well, for each block, okay, actually, yeah. So for each query, it moves b moves, right? So that means that that means, and it's kind of funky because this. Wait, am I messing this up? Yeah, I guess this is independent of queries. That doesn't make sense, right? No, I guess it makes sense. No, it makes sense because, like I said, it's always increasing, which it is funky to look at because you're like, this complexity doesn't even depend on queries, and it's true. I mean, at least the upper bound, right? Yeah. And then now we're doing the R, or this is the R move. What's the L move, right? Well, we have B blocks. We move B moves per Q. So yeah, so then it is just we move B moves per item and the Q queries. So it's just, so L is just equal to O of Q times B, right? And B, of course, we have to choose. Am I saying this? I hope I'm right. Maybe I messed something up. If I did, like I said, this is my first time. I learned this like an hour ago, so my apologies. But yeah, but each L, and we got Q of these queries, each of them doing at most B moves. You can also say O of B anyway, because maybe at the end of one block, you go from the beginning of one block to the end of the next block. But that's at most 2 times B anyway, right? So I'm like, so for each of the query, I mean, the analysis makes sense. I don't know. We'll double check it later. But yeah, Q times B, right? And then now the question is, well, what we have all these things, right? And that means that for all the queries, and there's no pre-processing actually, which is actually kind of shocking. Well, other than the sorting, if you the sorting pre-processing, and the sorting is just n log n because you're just sorting the n log n, right? So then now the complexity is going to be, you have the sorting as well. So it's going to be O of n log n for pre-processing, maybe. And then you have O of n over b times n plus q times b queries in total, right? Q is the number of queries. And then the question is, well, how do you optimize this? Well, note that we have not talked about what B should be. And it turns out that, what works very well for B is equal to square root of n, hence some part of its name or the idea, which is square root decomposition. And then now, if you just throw it back in, then this becomes another color, which is O of n times square root of n times n plus q times square root of n. And of course, this term is just square root of n. So this is equal to n plus q times square root of n. And that's it. That's the idea behind this algorithm. I know it took a long time to explain actually, but it's a very cute idea, honestly. It's very interesting. Something that I don't think I could come up with in a long time. And I looked at this problem knowing about square root decomposition. The first thing I noticed was that it was 10 to the 4th. I was like, huh, that's an interesting one. That is fast enough for square root decomposition if you know it. Though, yeah, but I only know the pre-processing version of it and not most, if you will. So I did not follow through on this one. And let's just look at the code. Yeah. Again, this times out in Python because, I don't know, Leetcode is silly. I probably could make things a little bit better with like using an actual heap instead of sorted list. But I converted this to Java and it was fine. So, oh, C++, sorry. And it was fine, so I don't know. And even made some optimization, which I removed because it's not good enough and also it's hard to read. But yeah, but as you can see, this is pretty basic, 53 lines, and it is what we said, and we'll go over it, right? So first, this is all data structure in how I did it. I want to go over really quickly. I was just playing around with some ideas. I had some ideas where I was using a sparse table for this problem. And the sparse table seemed okay because I thought that if you have different chunks, if you have the maximum, because of pigeonholes principle, the maximum. Okay, so there are two things about what. Let's step back a second about this problem. I forgot about. I want to go over most, but I forgot about some of the basis, which is that the threshold. The threshold actually doesn't matter in the sense that because you always want to get the max element. You have to keep track of the threshold to get the max element to see if it goes over it. But you never want, like for example, you never choose the second most because that just never is the answer. You always choose the most anyway. So the threshold is mostly useless. And then, yeah. And then from that, you go, well, then I only care about the max or the most common element in a range. And from that, I was like, okay, well, if you have a couple of ranges together, then the max element have to be the max element of one of the chunks, right? Meaning, another way, if you split a range to two halves, the max element has to be max element of one of them. So I thought that maybe I can kind of just take the max of the left, in this case, max of the right, and then do a binary search to kind of get the count within the range, and then kind of just, and there'll be log n candidates of these chunks, and each one of these we do a binary search, so it's like log n square, or log square n. So n or q log square n would be fast enough, and it should be. But unfortunately, it is wrong. The thing that I missed in my analysis is that tie breaking, right? So if you have multiple elements that tie for the most common, you have to consider all of them, right? And a very simple case is just that if you have like 10 elements, you have 5 unique values on one side, and I don't know, it doesn't matter what's on the other side, but one of the values that are overlapping with the second one, then that would be your most common, right? I don't want to dwell too long on it, just to say that it's wrong. You can watch the live portion to see where I got confused about all this, and then near the end, near the end, I was like, this has to be square root decomposition, so I kind of just Googled square root decomposition, checking to see where I missed. / sparse table, I was one of those two, was my gut feeling. Didn't feel segment tree. And then literally when I did that, Mo's algorithm is like in the front end. It talks about the most common element and stuff like that. So I was like, oh, this is literally what I'm looking for. And then I'm able to solve it as a result after reading it for like 5 to 10 minutes or something very quickly. You can watch the live portion. I did it live. But in any case, yeah, going back to the code, this is just to keep track of, allow me, so F keep tracks of the frequency, right? The window, and then also frequency within the window, but sorted so we can get the min element, right? And that's basically the idea. Is this min or max? Sorry, max element, or most frequent element, right? And yeah, and the update will tell you about it. It's just that when you update for the value x, we remove from the sorted list the key that we sorted by. We add by the increment, which is +1 or -1, and then we add it back in if it's greater than 0, right? And the reason why we have a negative x here is that we first sort by frequency, and then if they tie, we want to get the smallest number, right? But because we're doing a max on the list, then we want to make the smallest number the biggest number by negating everything, It's just a bit of a hack. Yeah. And then second, I create a new queries. The new query is just the same, except for it adds an index. Nothing too fancy here. You could see what I did here, right? And then I sort it. As I said, I sort by the block size, and then the right endpoint, so that the right endpoint goes from left to right. And of course, this is going to be n log n, even though it looks very funky. It is still n log n. It's just a key. And yeah, and the rest of the code is pretty basic. I start off with nothing, right? Inclusive range, right? So L and R is inclusive, and so I pre-allocate the space for all the indexes. And then now for every left-right threshold index, while left is less than left, we just move left, right? So when we move left to add, like with L is less than, let me write it in comments. Move L to left, adding along the way, right? And then this is move right R to right, adding along the way, right? And then now move L to left, subtracting along the way, right? Because now your L has too much stuff because your next query endpoint is to the right of the left. I know, sorry. You just kind of keep moving and subtracting along the way, and you can see, yeah. And remember that the way that I did it, L and R are inclusive, so the order of operation kind of just keep tracks of it, because basically if you move L to -1, subtract 1 from L, then now you want the new L to be inside the window, so you add it afterwards. Same thing with right, is that when you remove 1, that means that you want the one that you remove, which is the previous one before you add. So same thing. And then at the very end, we just get the max element. That's what I use sorted list for. We get the element and the count. Check to see if the count is over the threshold or equal to. If it is, then we set it to x, -x, because we sorted the other way. And otherwise, just -1. And that's it, right? The complexity we already went over, so I'm not going to go over it again, because it is a tricky thing to analyze, right, or to visualize for sure. And yeah, I urge that if you're curious, I think in these videos it is very easy for me to sound smart, even though I don't know anything. And so be cautious about internet people in general. With editing, the power of editing, anyone can look smart. So I don't know. This is why I do the channel I do, right? And then, but if you watch the live portion, but near the end, you'll see you see how I try to learn this and then figure it out. So maybe that is helpful or interesting anyway. I don't know. But yeah, that's what I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live in the contest now. Wow, a lot of people got a lot of this, so I'm not doing so well. Slash, a lot of people are cheating, but that's besides the point. Well, I mean, this is because everyone finished Q4 first, right, before I even looked at the problem. The leaderboard, I don't know how they regress, but anyway, okay, I digress on the regress. Alright. Recommend interviewee norms, queries. Left right threshold. Return where answer sub I is equal to the element in the subarray that appears at least threshold times. Highest frequency, the smallest. Okay, what does that mean? Okay, yeah, sub. What is sub? Oh, 0 and 5. Threshold is 4. Uh, 10 is 10 to the 4. Is it finally time for square root decomp? I feel like every time I try it, it's a little bit too slow, but that's usually 10 to the 5th and not 10 to the 4th. What's that, 10,000? Maybe that'll be fast enough. Let's see. A little hesitant because it is still very annoying to write square root decomp. Yeah, okay, fine. Square root decomp, how does that look like? I don't know how to write this anymore. It's been a while. I don't know. I don't know how to write this. Just say. No, I want size of the piece to be this. Is easier. Is it? Am I just overthinking it? Is it? I mean, there could be a lot of unique numbers, right? 10 to the 9. Threshold doesn't, yeah, fine. Threshold is pretty standard. Yeah, okay, fine. Man, so many people got it so fast too. I mean, okay, I always forget they're cheating. How do I even want to pre-process it? So we pre-process the first, we just order the square root. So L chunks, is that it? No, okay. I don't remember how to write it in a good way, so I guess we'll just have to do it in a dumb way. Actually, maybe something like that, and then we're going to do something like okay, something like this for the frequency table. I mean, frequency table, but we should probably do a trying to think for the maths in my head, because if it could have a lot of unique elements. Is this right? Does that even make sense? Because then you have to merge the frequency tables, and that's just not right. So if we force everything on the square root. The idea is that, but if each of these components have square root of n pieces, then the merge so each query is not square root of n anymore, right? You need to be able to do it in over one-ish to make it square root of n per query. That's not quite right. Even if it is square root decomp, that's not the way to do it. Oh yeah, I guess we could pre-process the queries. I always forget that. Maybe. Enter in a different order. Can I do it in a different order? I don't know. There's a sub-array things. Is it over weird? Sliding window or sweep line or sub-array? Does that even make sense? I don't know. I don't think so. I mean, apparently a lot of people know it, so either people are very smart or it is very Googleable. How would I write this? I don't know why I'm stuck in square root decomp. Let's see. Yeah. Is it just sparse table? No, that doesn't make sense either, because if not again, and then with each of those pieces have. Where is it? No, because if we do sparse table, each grouping each level will have at most an element in total. So, oh wait, no. But then the problem is that you don't have. Are you just segment tree? But it is just another data structure problem. Can I do anything with frequency? How much time do I have left? Oh wait, I guess. Well, within a sub-array, only the highest frequency matter. Slash typebreaker, right? So you don't really need everything. Because, okay. No, you still kinda, you can merge stuff because you could get caught up. But it is true that only the highest matter. And I take advantage of that. The threshold doesn't do anything other than an if statement, does it? Oh wait, no. No. It always just you always choose the highest frequency. Though none of these examples really show that for some reason. Oh no. Yeah, no. This is So you definitely choose the one with the highest frequency. So the threshold doesn't matter. Okay, so the threshold doesn't matter. I don't know why it took me so long to figure that out. So basically, you want to get the max element in a subarray, and then being able to get the frequency in a subarray. The frequency is pretty okay to get if you're able to get the max, right? I don't wonder if there's anything with what's his name, Freud or whatever, Washoe? No, some dude's majority algorithm. No, but it doesn't give you the. I mean, it gives you the majority, but it doesn't give you the mode, which may not be the majority. Why do I not know this? Can I do the queries backwards? Because the threshold doesn't matter, so now we have just these windows. Because the problem is when you do a scan, it's going to be square root of n, sure. But then you merge them, it's not going to be good enough. Well, I guess I can solve it in square root of n times log n. Because basically you only keep track of the most popular element, and you do a binary search, and there can be only square root n components. Maybe log n of them if I do it log n log n. No, square root of n makes more sense. But what's LCA most? No, least common, no, but what we want is the can we do sparse table? So basically sliding window on, then you just have to do 3 queries. That'll be fast enough, right? And you don't even use the sparse table, right? Though you can. Well, I mean, the sparse table doesn't do anything, but we can do with square root of n. What is log n? Is that gonna be too? Is that fast enough? I think it's right, but I don't know if it's fast enough. So I have an n or q log square n algorithm. I guess that's way. But square root of n is gonna be slower. So square root of n times log n is also bad. So no, that's not right. The problem is that, oh no, is it pigeonhole? I mean, it would be pigeonhole if they're disjoint sets. But if they're joint sets, there's log n of them, so log square n. Because if there's an intersection, then the pigeonhole no longer holds. Okay, I buy that. Okay. I don't know. I don't know how I feel about this far. I don't think it's going to be decom. I was hoping, but maybe not. Okay, really fast. I have 58 minutes. I think I'm okay. I've spent 50 minutes thinking about it. Alright, so then what do we want to do? sparse table. Okay. I forget how to do sparse table. I have code. Hang on. I don't think it's the code for this though. No, my thing is down. I can't find. I should just write. I mean, at this point, I'm not. I'm not saving any time looking for old code. Not to MFA. Okay. Okay, I can't find it. Okay, so then let's just say. I guess we can just keep going, right? So we have. So then now this is for one element. Alright, so then and then we have let's see. My site file loaded. Right. I forget how to do. I mean, I don't forget, but I'm trying to write it not in a dumb way. I guess I did not implement this in a not dumb way anyway. All right, so then here we have what do we want to say? Okay, so this is like 1. Right, so for range of from 0 to n minus 0, right? So we want to sort it as. This is so expensive though. Actually, isn't in collections or in counter most common? I wonder what the time complexity of the most common is. Most common is O of n. That's useless. Yeah, that is useless. Basically, we just want a heap, right? And now here, I guess technically now the way that we wrote it, this is going to be 2 to the L or the L. This is wrong. Nope. And then now and then now we have f of num sub I with s something like this, right? And oops. No, this is the last number. We run it this way. It's greater than 1. Something like this, right? And then now we want to get the min. No, we want to get the max. So that is frequency x. Then now, do we need the frequency? Maybe we don't. I don't know. Do we need a frequency? I don't know, but yeah. Then now st sub L. I'm gonna append x, right? That's basically the idea, just having the frequency things. This right. Do a spin, see if it crashes. Oh, I forgot to append an empty thingy. Okay. Oh, L is 1, that's why. Is it L minus 1? Yeah, I guess so. Well, L is just 0, actually, because 2 to the 1 is... Okay, I'm just dumb. Okay. Is an F a counter? How can it go out of bounds? Oh, num sub I can go out of bounds. Oh, this is could be smaller than n. Oh, this is just wrong. This is... Oops. Maybe even equal to. Actually, I don't know. I think, whatever. I don't think that's too much. Okay, it runs very slowly, maybe, possibly. How long does it take? No, just Leetcode being Leetcode things. Okay, so let's spot test. So this is... No, for L is equal to 1, this is clearly wrong. This should be the initial array. So that's not great. Oh, I didn't subtract from the... Okay. That I knew I wanted to do that. It's so expensive. Okay, fine. I mean, this is right. It's just I don't know that this is going to be fast enough for this. this is by definition should be true, right? Okay. Oh, still wrong. Even with the document, double check. I'm missing an element, so there's something. So if I is 0, this is going to be 1. Okay. Should be wrong. Oh, I forgot the initial one. That's why. That I actually knew. I was like, remember the initial thing because you did it in a weird way. Oh, so this should be out here, but I guess it should be just the biggest one. Doesn't matter. Okay. I guess just here. Okay. I mean, this is off by 1, but so it's no good. Why is it off by 1? 1 1 2 2. I mean, this is right. So then why is it? Did I mess up something on the SL -1? Well, maybe the SL is not right then. Oh, I'm doing the wrong thing. Okay, 1 1 1 1 1 2 1 2 1 1 1 1 1 2 2 1. Oh, maybe that's the next one. Yeah, okay, fine. There's only 6 elements. So then why is this giving me wrong answer for this? Oh, because I did this before I remove. I need to remove first. Dumbo. Come on, sliding windows, basics, Larry. Okay. 1 2. Okay, so that's good. This is of length 2. Oh, and I got the tiebreaker right. Nope, I do not. Choosing smallest number. Nope, I do not tiebreaker right, but that's fine. That's an easy fix. Because, yeah, okay, so that should be a 1. This is a 2. This is a 1. This is, so then it should be 1 1 2 1 1. And then for 4 elements, this should be a 1 1 1. Right? Okay. That means that we have the tie break on. It's actually kind of annoying. I mean, it's fine, but annoying. The key just has to be all negative. Okay, so that, now this is where we want double checking real quick. 3 2 3 2 3. Okay, well. Okay, so then now. Okay, so that's the fast table, and then now I don't know if this is fast enough to be honest, but we'll see. Maybe I should have done it in another language. Okay, so left, right, threshold. So then now you have all these pieces, right? Yeah, okay. Maybe C for consider. So then, how do I do? I always forget how to do the binary merging things. I guess it's not that bad. It is. Basically, you want to get the length. The length is going to be right minus left plus 1. Yep, okay, that makes sense. And then now, in terms of max L, which is, I guess L is actually the biggest number so far. Okay, so this bit is, then we have to take the progress from our current left. Something like this. Am I doing it right? If I is 0, the 1 is 0, we move over 1, we get a consideration of, I guess there should be a set just to make it slightly faster. And then it is the st of I, and that's it actually, right? No, st of I of current. Okay. Right, and let's see real quick. I don't know if this is right at all. Okay, actually. Yeah, okay, fine. I'll just print C real quick. So that it, okay, let's get rid of the other print statements real quick as well. Dunk. Is that it? I think I have one more spot, right? Maybe I don't. Nope, I do have one more spot. It should be here somewhere. Oh no, it's, oh. Oh, is that the end? Is it? I don't know, I print this. Okay, so that's fine. Actually, that's intentional. I'm dumb. Okay, so 1, 1, 1. Why? 0, 5. It's 1. Okay. 0, 3 is 1. That should be right as a consideration because that's perfectly 4. And 2, 3. 0, 1, 2, 3. 0, 1, 2, 3 is not right. Okay, that's a little bit sad. Why? Why is this not a 2? Okay, let's print st again just to make sure. So it should go. Okay, the number is 2. Oh, I don't have the L. No, that should be fine. Update current. Oh, current is 0. I'm dumb. Zero's left. What am I doing? How did I don't know how that happened. Okay, so this is expected. Okay, all right. I mean, I still don't know if this is right, but it's looking better. Just comment it out. So then now these are reconsidered. Now the other part is just more straightforward processing. I actually, I mean, I didn't forget per se, but I was like, oh, I'll hold it off until later for some reason. And again, I don't know if this is fast enough. It's gonna be n log square n. Okay, and then now. Press is best count is equal to 0, best index, or best number is equal to also 0, say. Is 0 possible input? No, okay. -1 if none exists. I guess maybe we just put -1 if 0. But okay, so then now we do f of x d, oops, of inclusive, okay. This goes to the next one, so I think this should be right? Oops. Oh, I guess I only do that. PC is greater than equal to threshold. Did I just call threshold? Yes, but spelled correctly. And yeah. Alright, I mean, moment of truth, or a preliminary moment of truth, okay. By d f of x, right? Oh, it's not f of x, it's indexes of x. Okay, not that bad. One negative, 1, 2. Again, I don't know if this is fast enough. I would do a big number test, but I don't even think it matters that much, in the sense that I don't know. Oh, that's actually surprisingly fast. I guess it's all ones, that's why. So maybe x. So something funky like this. Just all unique numbers. Still pretty fast. And then what we want then is queries. Whatever, it looks fast enough. I mean, if it may not be fast enough, but it looks fast enough for me to kind of YOLO submit. I mean, it was still too slow. Oh, just wrong. I mean, this seems clearly an off by 1 situation, so that's fine, maybe. I should have tested this case, though. This feels like a very testable case. I was worried about TLE. Why am I getting wrong here, though? It's fine. We have 34 minutes, actually not too much time. But, oh. Did I click on the right button? I think I did. Okay. Oh, we just don't construct. Okay, well, that would do it. Let's see. I guess this is where the I gotta test that case. Well, I was like, oh, I can do it later, but then I just forgot. Or I forgot to check if I do handle it later. Because there was a moment. Is this still right? Just want to make sure for the other ones. Yeah, look okay. No timeout, please. I also wouldn't be surprised if it does. Oh, wrong answer. It's surprising, actually. I mean, it is based on pigeonhole, so 12. Which one is wrong? Okay, so 0, 1, 2, 3. I can't believe it. I mean, maybe it's just wrong. 0, 1, 2, 3, 4, 5. 0, 5, 2. 0, 5. Okay. That seems pretty reasonable for me to, or should have been right. Maybe I'm off by 1. 4 and 2, right? What's it? So we're looking for the 052, 3 and 12. Why do I not consider 10? Oh, maybe there's some weird tie breaking thing. Oh, because of the tie breaking within a number or within the range. Huh. Okay. So if that's tough. Huh. So this would work if there's no. Well, that's not even true. But I think my pigeonhole was just a little bit off as a result. Because now you have two numbers that are both contending, and I just picked 3 instead of 10, and because I picked these two as chunks, and then as a result, the 10 gets split up in the tie break because of the tie. Ooh. I don't know. I don't know if I know how to fix this. I mean, this is already kind of tight on timing, right? How much did it take? I mean, there are different combinations, but that's just so tricky. Huh. How would you do it? Oh, that is a bad input, or like a bad input for me. Perfectly, and I don't know. I just takes so long to load. They're just looking at my submissions from like the last 5 minutes or so. Would have been good. Okay, well, I don't know what Leetcode's doing half the time. Huh. I mean, the problem is that anytime there's a tiebreaker, that's going to happen. If you just pick the wrong one, what you need for majority is that you can say all of them. Unless there's like a... Oh man, I really did not consider this one. I don't know why I Leetcode. Can you do your one thing right? Yeah. Because I'm just curious about the timing. And it doesn't say here for whatever reason. I don't know now. I mean, I don't even know if any reasonable processing this can, you know. I was thinking there are log and chunks. Do log and work on log and do. But because they're tied, I mean, that's not even a thing, right? In the sense that you add one more number and then it goes to, yeah, like if it goes from, you know, this num, except for this one is a 10, then in that case, you would still have the same issue depending on the order in which you process these chunks. Wow. Wow, I mean, I have no idea how to deal with tiebreakers. I mean, the other input was dumb for me, but this one I actually don't know. That's terrible. Like there's no type breaking rule that makes sense for me. I mean, in a greedy way, you have to consider all of them. And then at that time, yeah, and then you just have an entire input of unique numbers. Then you have to go through all of them every time, and that is just slow. Huh. And today I am not able to solve any problems. Because the problem is that if you just use chunks of 4, like you do here, and then you can still kind of get lost in numbers. Is that true? Yeah, because imagine you have the basically my sparse table is just a candidate thing, right? So we have to figure out how to get more candidates. The problem is the tie breaking. The idea is conceptually okay, I guess. Maybe not anymore. Just one of those days, I suppose. Even with square root decomp is the same thing, isn't it? At least the way that I'm figuring about it. Maybe there's another way of figuring about it. Hmm. I mean, I don't know. I don't. Yeah, try to prove from first principles. Yeah, maybe it's time to retire. Hmm. Hmm. Yeah, I have no idea. I think the worst part is that this is private Googleable, which is why so many people got it. It's either that or it's just like a textbook thing that I don't know about. I mean, 10 to the 4th usually it's like a square decomp thing, but maybe I'm just not understanding what I need to do for a square root decomp. I don't know, maybe I could get away with n log square n, but then there's this thing with no, that's too big. It's gonna be n over 2. Each of these, what was n over 2 is n minus 1, and each of those has 2 elements. That ends up being n squared, isn't it? Yeah, okay. Now that's n squared. Oh, it was 720 and then go for my one. I have no idea how to do this. Anyway. Not gonna lie, I am just reading up on square root decomposition and wondering if I'm missing anything. In case you're wondering, I mean, I don't know. I don't know how to solve this one. I think it's either square root decompose sparse table. None of the complexity really makes sense otherwise. Maybe segment tree if I don't know it, but yeah, we have another 12 minutes. Might as well use it to learn. Let me actually screenshot the leaderboard real quick for sadness. But that's what hey, that's the issue I'm having. At the mode of its range, the number that appears the most often. So then we don't perform the merge stuff fast enough anymore. Yeah, that's. Wait a second. I guess here we're learning together. Okay, use a different. Left index. What? Oh, okay. I mean, I never learned most actually, and apparently you didn't need to get to be a red top coder back then. So I think people are just running out of ideas and they're just doing crazy things just because they can. Because I feel like it's one of those things where once you learn it, it's not interesting. So I don't know why. So I don't bother learning it the first time because it's not interesting as a problem solving thing in general. Maybe this is though. I'm just saying in general. There are a lot of things like that. Okay. Okay. So it's saying that we store the results for each block, and then because we only kind of grow left and right into the adjacent blocks. Oh, I mean, there's code here, which maybe is a little bit too whatever, but I'm trying to just understanding it first. And this thing still doesn't load. Alright, fine. We have 9 minutes. Man, this is very short detail. I mean, they give you an idea, but they don't really explain it. We will first. Left index is in. Okay, I mean, that's fine. We can sort the queries, we can pre-process the queries, that's easy. Right index of the queries, that also feels fine. Oh, because then you always just grow, and then you could skip ahead either one element at a time. Okay, I mean, I kind of get it, but how does that stop it from? I mean, I guess the square root part doesn't. It's confusing to me necessarily. Or like, where's the time saving coming from if you just start with one block and then just kind of keep extending? I mean, the idea is fine, and then you go to the next query, which I guess you shrink on the left side, right? So the left side will always keep shrinking, but then the right side you also want to shrink on the right side. Oh, but then I see, because you can shrink. No, but then you just keep going, right? Oh, you kind of make. I guess one way you could do. I think you could subtract from the blocks and then go again, but if you do it that way, I don't know how that's not n squared though. I guess that's the problem. Yeah, I mean, we know how to do that. I mean, I basically wrote this already, honestly. Of course, that's what we're doing. Okay. Oh, I guess this is the part that I was confused about, that they're answering. I mean, my confusion about this is then like, where does the pre-processing help? Do we even pre-process? This part is fine. Which was this again? Oh, yeah, that part. Okay. So we don't even have to pre-process. Is that right? I guess that's the part I was confused about. All right, let's try it. We have 6 minutes. We're not gonna get it, but that's fine. We already submitted a couple of times. So Leetcode is very bad about. Leetcode is sometimes very weird about like when my time ends, it goes away. So okay, so then now we want to say we want to sort by a block, right? So right, so block is equal to say square. I actually don't know that algorithm. I'm not gonna lie. I think of I know square root decomp in general, but not the Mohs algorithm. Apparently, there's this proof. I mean, SL makes sense. I still don't know how. I mean, the left side I get, but I still don't know how the current right part move. Because this could go all the way to back to the beginning, right? Like, can you just go like back and forth and back? I mean, you probably sort it, but so that you just kind of go sweep, but then. Oh, yeah. I mean, this is the thing we're talking about, but I still don't get how the right movement part. Oh, wait. I guess I missed this part. All the blocks have been left. So then. Oh, yeah. This is S and. Oh. Oh. Wow, that math. Okay, I'm just really bad at math. Okay, I get it. Because you go, because there are n. It's not n elements. It's n over square root of n elements. And so, because you're only doing it on, so then it's gonna be n. Oh, that is. I am not a smart boy. I guess that's what I'm gonna say. We have 3 minutes. We're not gonna finish this. It's fine. We learned something. This is kind of cool. I don't know that. I mean, I didn't know it. But yeah, can I rewrite this in a good way? Let's just say, okay. Maybe we have something like t increment, right? I'm just basically copy and pasting from this. And what I want is, yeah. What is T? I don't think I need T. What would I have T for? Okay. Okay, so that's basically what I want. Don't need this anymore. And in fact, I really submitted it, so I don't think I need most of this anymore. Okay. And now we want to sort the queries in order. So we don't even do the square root decomp by itself. Okay. Block size. I guess within the block size we can sort as well. So basically we want to. Oh, we have to sort the queries by that, right? Okay, yeah. Never learned it. But any idea that you can learn in like 5 minutes and then solve the problem means that the problem setter is this is not a good problem, if you ask me. Okay. Yeah. Let's go queues. We want to sort by. Oh, I guess it doesn't matter. I mean, it matters, but there's no natural sorting order. So we want to. What am I writing? There's that. So we want to sort by the block order. Put in a function, maybe. Yeah, okay, let's put in a function. And it's just return x. So block of. I guess I could have done that actually. X of 0 is to the left, and then there's this like weird alternating thing. All right. Which honestly, I don't even want to optimize. It's fine. We don't have to. Well, we still want to sort by from going from left to right, so that's fine. Yeah. I mean, we'll do a little bit of resetting. It's not optimal, but it's fine. Okay. So then now, yeah, we worry about correctness for now, and the contest just finished, and I didn't finish it. Oh well. But I guess I learned something today, so that's good. It's always what I'm hoping for, something that I can learn from. Okay, and you know, and now I know some people ask me how I learn stuff, and this is how I learn stuff. Like I look at the idea, I don't look at the code that much, but once I look, you know, then I try to implement to my best understanding, and maybe my best understanding is wrong. So yeah, okay, so sort by block size. Yeah, that's clever though, because the left side only moves because they're all in one block. The left side moves at most of n altogether by definition. Well, I guess within the same block size. Huh. I'm trying to think. If we're sorted by the same block size, why would we not just... I was going to say, why don't we just sort by x of 0 and not block? I mean, why does the block matter? But the block matters because you want to group you want to sort by the right side because this thing is not as interesting as because you want to group them. Wow, I mean, that's such a... I mean, you know, it's named after someone, right? Mo. Is Mo a person? So, okay. Yeah. Okay, what else am I doing? Okay, so now we have the queries. We want to answer the queries. Okay, we have everything set up, right? So then now we have for left, right, threshold, index in QS. Okay, right. So then now we just start by and we can start by saying, I don't know, the current left is equal to just the first one, really. I mean, you could set it to 0 too, I think, but maybe that's fine. I don't know. But we just set to the left of the first element, so then we can just grow the first one, right? So then now it just becomes a straightforward thing, right? Because then now, while L is greater than left, or may have to worry about off by ones, but that's fine. So while L is greater than left, then we just decrement by 1, and then we we add L. No, L is already included, so we subtract 1 and then we add it, right? So that means that we have update num sub L with +1, right? And now, well, okay, expand, right? So left and right is inclusive. No, it's not inclusive because that otherwise, I guess maybe this should be this to contain no. Now it is inclusive. Okay, I like it inclusive. Okay, so then while left is less than left, I think technically for it to be inclusive, this actually removes first. Is that it? I mean, that's such a silly problem. SL of the max element and maybe negative, right? And that's it. Hopefully. This is, no, that's right. Is this right? I mean, the first 3 is right. How long did that take anyway? Yeah, no time. Oh, it's the wrong answer, so not so bad. Oh, I forgot to do the threshold thing. Okay, fine. We're gonna count and x. Okay, so if count is greater than equal to threshold, then answer index is equal to negative x. Else, okay. I get it. It's hard to tell. Okay. All right, let's go YOLO submit. I mean, I expect this to be wrong, honestly. It's my first time just coding it from learning it like 5 minutes ago or whatever it is. So, got a wrong answer. That's okay. See what we're wrong at. Oh, timeout. Okay. So maybe we do need to make that optimization. I'm just trying to see whether I have any obvious optimizations. I don't think so. I mean, like this one, we do, but yeah, so maybe we could do some optimization here. Because, okay, I mean, it's such a unnecessary, I don't know, I just feel like it's not in the spirit of things, but how do I want to write it? Okay, so basically, if we can maybe do something like right if block something like this, right? I mean, it should still be right for sure. Is it fast enough though? I don't know. We only missed by 5 test cases, so maybe that's just fast enough. This is a big case though, big boy case. And that's good because of it. I should have tested. I mean, well, no, it is after the contest. I don't care that much anymore. But it's still too slow. Am I missing some critical? Missing by block. Equip them by block, okay. I mean, this part is sketch for sure. But no. I don't know how to figure the timing out because I don't know this problem enough or this algo enough. Let's see. Q dot square root of f of the remove functions. Okay. Yeah, I remember seeing this, so, but yeah, I mean that's basically what I implemented actually. Huh. Well, this is a comparator instead of a key-based thing, but the sorting is not the part that is killing the time, though. It is probably this thing and probably as a result of these things. Am I doing anything crazily wrong? Don't think so. What is n here? With 10,000? So 100 is the box size? I guess it just doesn't show. Okay. I just want to check real quick if what the timing is on the other components. I don't know why this is so long though. So definitely Leetcode maybe just having issues in general. Like this should not be time limited, so maybe something else is wrong, right? Oh no, this is not pass. This is a brick. Okay, never mind. I'm just being dumb. I am the one who is wrong today. Okay, so that is pretty fast, but that's nothing, of course. But that means that, okay, so then just want to double check that all the other stuff is okay. This means that this is a little bit slow, which is unfortunate. Like maybe we could cache this, but it doesn't even matter, right? Because even on the other thing, it doesn't change anything. So I don't think that's quite the reason. It is all these updates that is the reason. Am I doing it wrong? Actually, yeah, I mean, this is basically first principles, right? So I don't know how to do it quite better. And this is the comparator. I mean, I guess yeah, it's just Java time. I don't want to spend too much time trying to figure, because I did all the obvious stuff. Maybe use a. I mean, in other languages, it's way easier, right? Because we don't need. Because I think map already. Wait, let me ask. Oh, map sorts by key. Okay, well, let's take a look at this ChatGPT C++ solution. Is it at least right? Okay, YOLO submit. I'm too tired to even think, but it doesn't time out. So okay, so I would have been annoyed. Oh no, time limit exceeded anyway. Okay, what am I missing? Oh no, accepted. I don't know. So okay, so there are multiple silly solutions on this one. Not solutions, just situations. Can I get this in Python? But also like this is so template-y that I don't even know how to think about it. Let's see. I mean, I'm trying to see whether even with the cheaters there's a Python solution. I mean, this. Okay, oh, there it is. That's crazy. I mean, they clearly know the algorithm or Google the right algorithm, but their best algorithm is not even a heap. It is just looking at all the items. How is that fast enough? I mean, I guess so, but why? Is the idea faster? I don't know. I mean, I could see it, I just don't. Okay. I mean, writing it like this does not make you cool. Though I guess my code is not that much greener. I mean, you cheated anyway, so I don't know. I'm so cynical of these days. Maybe he didn't cheat at the time, but I mean, it's very believable that people didn't cheat for this one just because it's Google, apparently. So yeah, that's why I wanted to write a heap, but I mean that would be faster, but it's just lazier for me. I don't know. That's all I have with this one. I am too lazy to kind of figure out how to do it. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.